Welcome to The Explainer. Today, we're taking a really fascinating macro to micro journey. We're going to start super wide, looking at the whole landscape of the 7th grade syllabus, and then we're zooming all the way in to solve a very specific everyday math problem. So let's jump right in. Educator Ping spent 7 years in middle school classrooms, and she perfectly captured that feeling of stepping into a math class. She remembers, and I quote here, "the sea of curious and sometimes anxious faces." It's just a great reminder, isn't it? Both students and teachers get butterflies when they're facing a tough curriculum. Humanizing that educational experience really builds empathy on both sides, especially when we look at exactly what these kids are taking on today. Here's our roadmap for the day. We're looking at the Class 7 shift, 7 engaging math hooks, mastering the unitary method, direct versus inverse proportion, and finally, real-world math applications. Section 1, the Class 7 shift. Navigating the 2026-27 CBSE syllabus. 7th grade is a massive shift. It's an absolutely crucial year for foundational growth. And honestly, you can see why just by looking at the sheer breadth of the academic landscape they have to navigate. The core curriculum is packed with heavy hitters. We're talking mathematics, science, social science, English, and Hindi, plus optional subjects like Sanskrit, Urdu, or IT. I mean, that is a massive cognitive load for a middle schooler. And you know what? The demands are actually growing. With the National Education Policy 2020 updates kicking in for the 2026 to 2027 academic year, students are now required to study 3 languages. That's 2 native Indian languages and 1 foreign language. Plus, they're integrating basic coding and vocational skills right into the curriculum. It really just goes to show how much is being asked of 7th graders today. Section 2. 7 engaging math hooks, sparking curiosity in the classroom. So, with a syllabus this demanding, we really have to put on our pedagogical lenses. How on earth do you grab a 7th grader's attention when they have all of those different subjects swirling around in their heads? Well, according to educators, the solution lies entirely in the first 5 minutes of the lesson. It's all about the hook. A hook is a teaching strategy that basically piques their curiosity and sets the tone right out of the gate. Congruent Math gives us a really fantastic breakdown of these proven strategies. Number 1, real-life applications. You got to show them why math actually matters today. Number 2, short videos under 5 minutes to give them a solid visual representation. 3, visuals and graphing, where students interpret data or, better yet, create the graphs themselves. 4, thought-provoking questions to build up that critical thinking. And finally, number 5, games and kinesthetic activities. Look, if you're a teacher or a parent, the takeaway here is absolutely crucial. Use movement, play, and real-world relevance to spark joy and make all that abstract math feel concrete. Section 3. Mastering the Unitary Method, turning abstract math into intuitive logic. All right, we are zooming our funnel right down to the student's desk right now to focus on one of the most practical topics in the entire 7th grade math syllabus. So what is it? Well, the unitary method is simply finding the value of a single unit from multiple units and then using that one single value to find the value of any required number of units. I actually really like to think of finding the value of 1 as this absolute secret weapon for solving complex ratio and proportion problems. Think about it. Once you know what one thing is worth, you can figure out literally anything. The formula behind this is just beautifully simple. The value of 1 unit equals the total value divided by the number of units. That's it. As your guide for this explainer, I really want to demystify this entirely. Unitary method sounds so fancy, but it is really just basic everyday logic. You find out what 1 costs, and then you just multiply to find out what 10 costs. Section 4, direct versus inverse proportion, understanding mathematical relationships. Okay, but before we can solve anything, we really have to understand how different quantities relate to one another in the real world, because they definitely don't all behave the same way. First, we have direct variation. This is where more items equals more cost. So you buy more apples, you pay more money. Makes sense, right? But then we have inverse variation, where more of one thing actually means less of another. A great example is workers. More workers means less time needed to finish a job. It is absolutely vital to grasp this distinction, because buying a dozen cupcakes works very differently, mathematically speaking, than hiring a construction crew. Section 5. Real-world math applications, putting theory into practice. So, we are now in the final stage of our funnel. Let's put the theory, those hooks, and the formulas to the ultimate test. Take a look at this direct variation problem from Orchids International School. If 24 cupcakes cost 480 rupees, what do 36 cupcakes cost? This is exactly the kind of real-world application that hooks a student's attention. Suddenly, we're not just doing math, we're talking about dessert. Let's solve it together. Step 1, we use our unitary method to find the value of just one cupcake. So 480 divided by 24 equals 20 rupees. Step 2, now that we have our secret weapon, the value of 1, we just multiply it by our target number. 20 rupees times 36 cupcakes equals 720 rupees. See how incredibly easily the unitary method solves the cupcake dilemma? All right, now let's challenge our brains a bit with an inverse variation problem. If 8 workers complete a job in 12 days, how long will 6 workers take? Now remember our rule from earlier. Fewer workers means the job is definitely going to take longer. The math has to reflect that real-world reality. Let's look at how the logic plays out here. For step 1, instead of finding the work of one day directly, we first have to find the total effort required to do the job. So 8 workers times 12 days gives us 96 worker days of total effort. Then step 2, we take that total effort and divide it among our new crew size. 96 divided by 6 workers equals 16 days. And it makes perfect sense, right? With fewer hands on deck, the timeline stretches out. This kind of math matters far, far beyond 7th grade. Finding the cost of groceries, calculating time and speed on road trips, managing your daily expenses, dividing up work among people, or even calculating percentages. All of those things rely on this exact same simple logic. Mastering this concept isn't just about passing a Tuesday night homework assignment, it is quite literally about building a lifelong skill. Which brings me to a final thought for you to chew on today. Take a look at your own life. Where did you subconsciously use the unitary method this week? Did you calculate the price of a gallon of gas? Maybe you figured out how many days a bag of coffee was going to last you. You are already using this math to navigate your everyday life. Keep that curiosity alive. And until next time, keep learning.